So today we're going to talk about graphing lines in slope-intercept form. So a quick little background as to why we start to look at slope-intercept form is we know the definition of a line is that we need 2 points to define a line. And just as a review, if I were just to draw a coordinate plane and put 1 point inside that coordinate plane, we don't know what line would go through it. It could be any of them. So if we have 2 points, so if I add a second point to this graph, there's only one line that could possibly go through it. So for example, sometimes we're able to get 2 points very easily. So if I have this standard form equation down here, we could just find the x and y intercept as our 2 points. So I've just shown the work there below. We could go ahead and find our x-intercept to be 4, 0, and then our y-intercept to be 0, 3. And once we do that, we'd be able to make a graph. We would plot our y-intercept, and we would plot our x-intercept, and we know that there's only one line connecting the two. However, at times we might not always have the ability to get 2 points on a line. So we can start to pair that with some other information. If we have 1 point on a line, so somewhere to start, and we know that lines always have a constant rate of change, we can use that constant rate of change to be able to get more points on the graph. And as long as we have 1 point to start with, and we have the ability to get more, well then we'd obviously be able to make our line. So like a quick example here, what I have pictured for us is there's 1 point on this graph here. And again, right now we don't necessarily know what line that would be without any more information. So they describe it to us as this point is on a line that follows a pattern. It follows this constant change. If x increases by 1, then y should increase by 2. So I can think of that as like a set of directions on how to get another point. So in the table here, what I can do is follow those directions. So if I increase x by 1, so from 0 plus 1, that'd bring me to 1, then my y value should go up by 2. So 3 plus 2 is 5. So I now know the point 1, 5 would also be on this line. So I could go over here and graph the point 1, 5. So now I have 2 points, and 2 points is all we need to make a line. Now that's where slope-intercept form of a line is going to be very, very helpful. Slope-intercept form of a line, first of all, is this general form. We call it y equals mx plus b. So the way that we want you to see it is y is alone. Right? Sometimes we might call that isolated. There's a number before x, and then there's some sort of number at the end. Now the reason we like this is that number before x, that m value, is our slope. And we know that the slope, we can interpret that as our constant change. And what we said in the last slide was that these were our directions to another point on the line. Now this b value over here, that is always going to turn out to be our y-intercept. Now we know it's going to be the y-intercept because if we plugged in x equals 0, which is the definition of every y-intercept, we see that y, m times 0 is nothing, y would always equal b. So our y-intercept is always that b value. Now with that b value, it's a point, right? So this is a point, but what we can think of it as is this is our starting point. So putting it all together, if we're given slope-intercept form of a line, so it gets the name because it tells you the slope in the equation, and we know that the slope is kind of like our directions on how to get to all the points on the line. And then the intercept comes from the fact that it tells you the y-intercept. Now for our purposes, what we can see here is that we have a starting point given to us in the equation. So it tells us where to start, and then it tells us how to get more points on the line. So we'd always have enough points to make a graph. So if we're going to graph this line given in slope-intercept form, we first need to kind of figure out two things. Where are we going to start? Right, and our starting point is always going to be the y-intercept. So in this case, the value that's given to us as the y-intercept is that number at the end. So the y-intercept is y equals -3. So as a point, we know that's 0, -3. So let's go ahead and plot that point right here. Here's 0, -3. This is where we're going to start. Now we should be able to use our slope. Our slope is the number before x, so our m value is 2. Now as a fraction, we know that's the change in y over the change in x. So I'm going to represent that as 2 over 1. So if I increase my y by 2, every time that my x value goes up 1. Or in other words, we can see this as the rise over the run. So now I have my directions on how to get to the next point. So I need to go up 2 and then over 1. This point is on the line. I can do that again. I can go up 2 and over 1. This point is on the line. Up 2 and over 1. So I started at my starting point, and I used my directions, or in other words, my slope, to get more points on the line, and then finally we are going to connect them with a dot, and we're going to put our arrows, remember, because we could have kept doing this forever and ever and ever. We just chose to stop there. So here we're supposed to graph another line given to us in slope-intercept form. So whenever we're graphing a line, we always want to have a starting point. And if we're given slope-intercept form, that's going to be our y-intercept. So our y-intercept is the number at the end. It's 2. So as a point, that's the point 0, 2. So we'd plot that point. This is where we're going to start. Now we need directions on how to get more points, because we need 2 of them and we only have 1. So our directions are this slope value here. So it tells us the slope of this line, m, is 3/4. And we know that 3 represents the rise, and then the 4 represents the run. So I would start at my point. I need to rise up 3, so 1, 2, 3, and I need to run over 4. 1, 2, 3, 4. And since it was a positive 4, I went in the positive direction. Since it's a positive 3, I'm going to increase it by 3 and go up. So 1, 2, 3, over 4. 1, 2, 3, 4. Now I could think of it in the other direction. Where would I have been if I would have went up 3 and over 4? So I can kind of go backwards too, right? So 1, 2, 3, 4. 1, 2, 3. If I were here, I could follow that pattern, right? I could rise up 3 and over 4. So we can kind of do that in any direction that we want. So now I have plenty of points, and that's enough points to go ahead and connect them with a line. Again, I'm putting an arrow because I could have done this for as many times as I wanted to. The last example given to us in slope-intercept form, I want us to specifically notice that there's a negative here. So that's the purpose of this problem. But before we do that, whenever we're graphing a line, we always need to have a starting point. And we know in this case, if we're given slope-intercept form, that's our y-intercept. So the y-intercept here is the number +4 for the y value. So if y equals +4, we got that when the x value was 0. Now we do need directions on how to get to the next point. And this is where that negative is going to come in. So the directions are always our slope. And it tells us here that our slope, our m value, is equal to -1/2. Now we want to specifically make sure that we know how to handle the negative. That negative can go on the top or the bottom, but not both. So we could see it as -1/2. Or we could see it as 1/-2. No matter which way we see it, we'll always have enough to make a graph, as long as we remember it's the rise over the run. So to make our graph here, we have to start at our starting point of 0, 4. 1 point is not enough to make the graph, so we need to get more points on this line. So first, let's pretend we wrote it this way. So if the rise was -1, that means we would go down 1, and then a positive number would be over 2. So I need to decrease my y's by 1 and increase my x's by 2. 1, 2. Let's do that again. So -1, so I'd go down 1, and then the rise is a positive 2, so I'd increase my x's by 2. Now, if I would have written it the other way, maybe I wrote it specifically like this, where my rise was a positive number, which would mean I need to increase my y's by a +1, but my x's on the bottom need to decrease by 2. So if I was at my starting point, again, I would need to increase my y value by 1, but when I did that, my x value would have needed to decrease by 2. So let's do it again. I could have increased my y value by 1, and then decreased my x value by 2. No matter which way we do it, we're always going to get the same line. And we can see that that rate of change, that rise over run, I'm always going down 1 and over 2. No matter how I draw it, over 2 and down 1. Down 1 and over 2. Or maybe over 2 and down 1. Lastly, we just put on our arrows to make sure that we're communicating. We could have done this forever and ever. We're just running out of time and space. The last part here is just to emphasize that the slope and y-intercept of an equation can only be seen in slope-intercept form. So I'm just going to kind of note that we must have, the slope-intercept form to know the slope and the intercept. I know that seems kind of redundant, but that's why it's called slope-intercept form, because it tells us slope-intercept form. So like the first two examples, number 1 and number 2, we can see that they are in slope-intercept form. The y value is by itself, there's a number before x, and then a number after x. So because these are in slope-intercept form, we are able to identify the slope and the y-intercept. So the slope here is 3. The slope at number 2, the number before x, is -3/4. The y-intercept of number 1 is 6, so the point is 0, 6. On number 2 here, the b value, which is our y-intercept, is also 6, so the y-intercept is the point 0, 6. But if we go down here and we look at numbers 3, and the second number 3, and then number 4, they are not in slope-intercept form. So we cannot immediately determine the slope or the b value. We have to do some other work. Now that could be one of two different things, or maybe 3 or 4. We got to kind of decide what to do here. So if we look at number 3, what we can do on number 3 is our goal is, can we turn it into slope-intercept form? So can we write or get y alone? So to do that, we can just subtract x from both sides. So y equals, and now I'm choosing to write the x term first because that's the order it is. So there was a -x, and then this 2 was positive, so -x plus 2. So now that it's in slope-intercept form, or maybe it's a little easier to see as -1x plus 2, I can see that the slope of this line, the number in front of x, was a -1, and the y-intercept at the end is a plus 2. So we can go ahead and say our slope is -1, and then our y-intercept was 2, or in other words, the point 0, 2. Now, for number 3, there's no way that we're ever going to be able to get y alone. Because there is no y. And if there is no y, we must recognize that therefore that means that this is a vertical line. So for a vertical line, the slope is undefined. Now if we think about the y-intercept of this line, if I were to draw the line x equals 2, it's a vertical line where x equals 2. So it never touches the y-axis. So our y-intercept is none. So there are some equations that cannot be put into slope-intercept form, especially the vertical ones, because they don't really have a slope that we can write, and they don't have a y-intercept. Now the last one, y equals -2, is already in slope-intercept form, but it might be helpful to re-see it, is there's no x's. So what that means, though, is that there were 0 x's. So 0 must have been the number in front of the x value. So we can see here that our slope was 0, and our y-intercept was -2, or in other words, the point 0, -2. The last thing that we should recognize, this is just a horizontal line. And we know that horizontal lines have a slope of 0.